nanotechnology has a lot of different aspects to it.
Nanotechnology involves looking at materials and structures that are very, very small.
I want to play with atoms. I want to position atoms.
Materials behaving in ways that are very unconventional, things we could never have predicted before.
Nanotechnology is well on its way to growing into a very remarkable activity.
It's thousands of a micrometer.
Smaller than you can even imagine being able to see.
There are huge opportunities.
We're building machines that are smaller than the diameter of your hair.
Smaller than what you could see with an optical microscope or even fancy electron microscopes. We're going down to very, very small scales. The exciting thing about nanostructured materials is that you can start to access material properties that you might not be able to otherwise. And these materials will have applications that are far-reaching in pretty much any corner of industry that you can think about, from computers to automobiles to aircraft.
The practical applications are clearly that we can build now transistors which will function with only a single electron. If you take transistors nowadays, there are many and they still need a lot of space. We can reduce the size to only a couple nanometers, which is the important issue here.
Having very small sensors as gyroscopes and accelerometers could really help enable a whole new class of small-scale satellites.
I want to make much, much smaller things. I make a CD-ROM that is a million times higher storage density than what you have in your computer.
One aspect of nanotechnology certainly would be in being able to create new types of diagnostics that would function at the single molecule level and thus detect extremely small quantities and low concentrations of toxins, for example, and other indications of disease.
It's possible that we're going to be able to diagnose diseases much faster than ever before and much more accurately.
You could have your individualized human genome just to your person on a little wristband in the hospital, and the doctors would right away know what kind of diseases or precautions they have to take.
We may even be able to cure those diseases thanks to nanotechnology.
You can't define it because it's so broad. Everyone who works in this field has a different idea of it. Many very innovative people are in this field, and so it keeps you away from being boxed in and into a certain way of thinking.
By nanotechnology, what we mean is we're taking individual atoms and manipulating them, getting them to do what we want, getting them to go where we want, to create new materials, new devices that have structures and functions that we couldn't possibly have imagined previously.
It's sort of the individual molecular cluster or individual molecule level to create new types of materials or new types of interfaces to materials.
Nanotechnology, the way engineers are developing, is coming down from the top. We are moving from large scale to micro to nano. Okay? While the biologists are coming from the other direction. They are coming from the proteins to the cells, to the organism, and they are intersecting in what we call typically the nanotechnology. And this is where I think the biggest development is going to be, because it is at the frontier between the two.
There's been a tremendous amount of growth at the University of Wisconsin in nanotechnology research.
Definitely, we are one of the premier research universities.
People of the state may not realize it, but this is actually a hotbed of nanotechnology. The University of Wisconsin has a number of very active research programs and also is at the cutting edge of the education forefront in educating our own students in nanotechnology as well as educating the general public in nanotechnology.
The stronghold is that you have a combination of chemistry, biology, and physics, which is all focused on engineering, and this is where you want to be in nanotechnology.
And there are other institutions where there's world-renowned kind of work going on, but maybe the barriers to interdisciplinary collaboration are somewhat higher and the history isn't as long. And so I think that there's a tremendous opportunity as well as a unique opportunity here to accelerate through to a leading kind of position in this nanotechnology world.
It's really exciting to be working with those students and thinking about some of the possibilities, some of the new things they're going to invent, some of the new materials they're going to get to work with.
There's so much research activity just starting up, and the exciting piece about it is that it's really wide open, and there's lots of opportunities to greatly impact people's lives.